everyone, it's Coach Fred here, and today I'm going to be going over the factor theorem. Again, this is one of the theorems that relates to polynomials. And so if we have a polynomial, f of x, and it has a factor of x minus k, well, what that means is that if you evaluate the function f at k, then you should get an output of 0. That would make it a factor, which would mean that k is 0 of the function, okay? So maybe it might be helpful. I always find it helpful to try and rewrite theorems in your own words and maybe use an example. So I might suggest that you do that now. But here's what I mean. It says, what is the value of k such that x minus 7 is a factor of the polynomial h of x equals 2x cubed minus 13x squared minus kx plus 105? Okay, well, if we think about that, if it's a factor, that means the function, if I took this away, I'll just take that away like that. That means the function has to equal 0, and that means you'd have to break it up into parts to see what the factors are. So first, again, we're always going to try to factor it, but in this case, it's not factorable. So I'm going to try synthetic division. I can use synthetic division over long division because that is a linear factor that we're trying to work with. Okay, so we know that if it's a factor, then the 0 would be 7, okay? Our coefficients would be 2, negative 13, negative k, and 105. And we know that when we do the synthetic division, we want to get a remainder of 0. That would mean that x minus 7 is a factor and that 7 is a root. Okay, all right, so what do? We walk through our process, but now we have a variable in our process. So 7 times 2 is 14, so I carry the 14 and then I add down, getting 1. Now here's where it gets tricky. 7 times 1 is 7. We add down, which would be negative k plus 7. Okay? All right, we multiply. So negative 7 times negative k, let me put that arrow there so I'm consistent, would give me negative 7k plus 49, and we add down. So that tells me that 105 minus 7k plus 49, we need that to equal 0. Okay, so 105 and 49 would be what? 154 minus 7k, is that right? Yeah, equals 0. So 154 equals 7k, and let's see, I think that's 22 equals k. So if k is 22, then x minus 7 is a factor. And the reason you knew you needed a remainder of 0 is because of the factor theorem. It would mean I'd have to have a remainder of 0, okay? All right, so it says, given your value of k above, can you find the remaining factors? Okay, so let's see what I mean by that. If k is 22, then this right here would be negative 15. So the depressed polynomial would then be 2x squared plus x minus 15. Okay, so then let's factor those. Let's factor that because it's a quadratic, so I'm going to try and factor that first. So I want the factors of 15, which are 1 and 15, 5 and 3. So it appears to be 5 and 3 minus plus. That would give me a positive 6 on the outside and negative 5 on the inside, which would give me a positive 1. Okay, so that means my entire polynomial is that. F of x or y. So could we sketch a graph? We certainly could. We have our we have some information now. We can see that the degree is 3. So I have a degree 3 polynomial. I've got my leading coefficient is positive, so I know it's going to be down, up. I know my x-intercepts are 5 halves, 0, negative 3, 0, and 7, 0. I know my y-intercept is, let's see, negative 5 times 3 times negative 7. So 35 times 3, which I think is 105, but I'm going to check that out. Yep, 105. Okay, so if I were to sketch a quick graph here, I've got 1, 2, 3, 4, 5, 6, 7, 2.5. So right about there, and then negative 3. Then I've got this x or y-intercept way up on the top at 105. And yes, I could find points in between everything. I'm not going to for this example because I'm just doing a quick sketch. So down, they're all multiplicity of 1. I'm going to go up. I'm going to turn around. I'm going to go through. I'm going to turn around somewhere, and I'm going to go up. And there's my polynomial. All right, guys. So you can see that the remainder theorem and the factor theorem really can be helpful. We're going to practice these in the next couple of days. Okay? Have a great day.